Okay, today we're going to talk about section 6.7 and 6.8. We're going to do these together because they're going to need to do some of it in class. It's more easily used on the calculator, so we'll do some of that. Hopefully you'll be able to see the calculator and we'll be able to work with that some on this, and some we'll do in class as activities. So if we have a polar graph, an equation for it, like this. The reason we would use this polar form is because if we tried to use rectangular form, it would be really difficult to deal with. Because if we change this to rectangular form, we get multiply by r on both sides, and that gives us what we can work with. We have x squared plus y squared equals 3 times the square root of x squared plus y squared plus 2 times y. And this, if we want to graph that, we need it in y equals form or some other form that we can deal with to do by hand. If we want to put it in our calculator, though, we've got to have it in y equals form. So the easier way to go is to use this polar form because it's nice and simple. Now, on our calculator, if you push the mode button, you'll see here where it says on this fourth line down, it says FUNC, that's function mode, and then there's parametric mode. This is polar mode, POL. So if you change your calculator to polar mode and then go to your y equals, and the y equals has r instead of y because it's polar mode. So we have r equals a function of theta, and we can type in this graph here, 3 plus 2 times the sine of theta. And we end up with a graph. Let's get a better window than that. If you graph it on a standard plot, it looks like this. Now, the trick with polar graphs is when you graph it, you have to be really conscious of your window because your window is going to change what it looks like. So you want to be able to see the whole picture. And we'll do an activity in class to show you how really important this is. But if you do start out with a standard window and then go to your window and adjust it so that it fits more what you have. So for x, -5 to 5 is probably good. And for y, we can probably go -5 to maybe 8. Let's see how that works. So that works a little bit better. So you can see there on the graph here, it's kind of like an ellipse, but it's a little bit indented. This is called a limicon. On page 327 to page 328 of your book, there's a chart, and it tells you all different kinds of polar graphs, limicons and roses and spirals and all those kinds of different things and what their form looks like. You need to study this chart, and then you need to either Xerox it and put it on the back of your conics formula sheet, or you can write it on your 3x5 card or whatever so that you have it to go with your conics formula sheet. But we're not going to do a whole lot of this by hand. Most of this by hand, you would plot points, pick theta values and make a chart with r values, and you plot points on that polar graph paper. And some of that is good, and you need to know how to do that, and we'll look at that a little bit. But for the most part, you need to be comfortable with what the equation is going to give you. You need to be able to look at the equation and know that this is a limicon because of this, the way the equation is set up. So when your calculator gives you an answer, you can look at it and make sure you're in the right window so that it's looking like you need it to. All right, so let's try a couple. Let's say we want to graph the equation r equals 9. Well, if you look on your chart, you notice that if you have r equals a number, that's a circle centered at 0, 0 with a radius of in this case, 9. That's what this means. Remember on your polar graph paper, what this means is we're going out from the pole 9 units. So we'll go out from the pole 9 units. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, we go and we get 9 units. But because it's just r equals 9, every time it's 9 units there and 9 here and here and here and here and here until it makes a circle. So if we look at our calculator, we can type in the equation and then do a standard window to start with. Now remember, this is a circle, but our calculator is not showing us a circle because it's not a square window. So if you do a square window by doing zoom square, then you'll be able to see. A square window works best with the polar coordinates because it gives you a more accurate shape. So you need to use that instead of just saying zoom standard, to do the zoom square, which is choice 5. So that'll help you. Now, what if we have r equals 9 times the cosine of theta? Well, if you look at your chart, you'll see that this is also a circle, but the circle for this one is centered at the half of this one, so 9 halves, comma, 0 degrees, and its radius is half of that, 9 halves. So when we come over here to graph this, if we have 9 times the cosine of theta, when we graph it, we see the radius is half of what it was for the other one, and it's shifted over. Now, what about if we have a different one? What if we have r equals 9 times the cosine of 2 theta? If you look at your chart, you'll see that this is a rose, and you have a is 9 and n equals 2. Because our n is even, that means we're going to have 4 petals, 9 units long. Now, what does that mean? Well, what it means is it looks like a flower with 4 petals. So if we come over here to graph it, and we have 9 times the cosine of 2 theta, and we graph that in our square window, this is what we get. It's a rose, looks like a flower, with 4 petals. Each of those 4 petals is 9 units from the pole out to its outer part here, 9 units long. So on the chart, that's how we knew these things, and then we used our calculator to graph it. Make sure you can decide the type and you can describe it before you start using the calculator. That's pretty much all you need to do with these polar graphs. If you know your chart and you can figure out what kind it's going to be and describe it a little bit, and then put it in the calculator and draw a sketch, then you're going to be good to go on 6.7 and 6.8. We'll work on some activities in class to show you different things about how to graph these and how different windows and things like that change it, and different values for theta and things like that. So be prepared with your notes and make sure you've read both 6.7 and 6.8 because we're going to do those together so that we can work on these together in class.